Are you able to see my screen?
Yeah, it's visible. Yeah.
So yeah, so as Utkarsh said, we are going to deal with AI and the biases caused by AI. So I myself, I'm Anusree. I'm an AI engineer at Innovation Incubator Advisory. I work on recommendation system to defect detection systems. So before going or diving deep into the biases caused by AI, let's talk about the human biases in general at first. Okay. So what do you think? We humans are biased in the most professional atmosphere. Like, for example, a court in the court, the judges are biased. It may be an unconscious bias or a conscious bias. It's just we are telling that we can be biased in a situation where, due to the societal conditioning or the societal construct that we grew up, and this can be unconscious because whenever a judge make a decision on the court or make a judgment, uh, he or she or that particular person makes a judgment with by relating himself or herself to the particular accused or the victim, and then make a judgment. So in many cases, while making a decision in a professional setting, we are also biased unconsciously. So I will show you one image. So if I ask you to describe this image with some words, a few words, not a sentence, like how would you describe this image? Can anybody unmute and tell me two or three words on describing this image?
Dhyan has said male elephant. He's typing in the chat box.
Okay, can you read it?
Dhyan has said a male elephant.
Okay, male elephant, cool. Anybody else want to try? Okay, so I think that's it. We can say that this elephant is tall. It has long trunks, fluffy ears. Maybe it's an African elephant. We can say all these things. Okay. So now I'm gonna show you another picture, and you have to repeat the same activity. Okay. How will you describe this elephant? Is any answers coming up in the chat box?
As of now, not yet any.
Okay.
Okay.
Do anyone want to try? Can you just make a few words on what to describe this picture?
A white elephant, an
Okay.
event with an elephant. Like, yeah, answers are
Yeah.
coming. Yeah.
Okay. Cool. So that's what I want to just tell you. When I showed you an elephant, at first, initially a black elephant, nobody said me that it was a black elephant. He told me that it was a male elephant. It can be an African elephant, something like that. But when I showed you this image, the first answer was a white elephant. So why is it so? Our mind are preconditioned to something that we are very used to. If I show the same image to somebody in Thailand, he would have said the answers like a big elephant, a tall elephant, elephant with a very long trunk, something like that, because they are used to white elephants. And so that is the reason. So that is the main reason why we are having this session, because uh, in each part of the world, we are accustomed to different things. And the things that we create are also based on that. For example, so when we create an AI product, it's not just for Indian users, or it's not just for particular country. We are creating a product for the whole world using AI. So that means the product that we make is very inclusive, considering the population of the world, considering all their experiences and things. So now I'm going to show you two slides, which are from the MIT lectures of Ava Solemni. So I'm going to show you that. So this is a slide from the MIT lecture on biases. So here she is telling you that there's a CNN image class. This is an image classification model based on a CNN model. So here we are actually giving an input of bride. Okay, basically a Western bride. Okay, so this we are inputting this Western bride image into the CNN model, and we are going to predict the words which is associated with this particular image. So what it predicted was it is a bride, dress, ceremony, woman, wedding, etc. So so what this model does is we input an image and it just give you some words which can describe this particular image. So this is a CNN classifier. So you now see this. Okay, now I'm going to show you another slide with an Indian bride. So Indian or something like an Asian bride, we can say that in general. So this is a bride, but the predictive classes that we got is clothing, event, costume, red, performance, art. Nowhere in this predicted labels we can see something which is even remotely related to even a human being. We don't want even a bride. No, nothing related to a human being was even predicted. Here you can see it was predicted as a woman, it was predicted as a bride. But here it is just clothing, event, costume, red, performance art. So that is why I said when we are creating something, we have to consider the whole world. So these are the examples of biases in image classification. So when we consider, when we actually did something called a statistics of the models created, the ML models created, uh, we have uh, we have actually found a correlation between the predicted labels have been mostly correlated to very high income. Because the thing is, all the image data set or all that whatever data set that we are using is actually obtained from developed countries like America or from continents like Europe. So what happens is that there the images of how do we actually get the data set? Either it's from the Kaggle or we actually scrape the Instagram to get images. So what happened is that most of the sources are filled with data that is being collected from the developed countries like America or maybe mostly from countries like USA and Canada. And what happened is that mostly their lifestyles are the images that we get from Instagram by scraping by scraping Instagram are lifestyles, and our data reflects a rich lifestyle, and or maybe more like Western civilization, and all the data that we get, the predictions that we get, is also related to that. For example, uh, let's say a spice bottle that is used in a poor household and a rich household is different. So if you are
Anushree, I guess you got mute.
am I audible now?
Yes, you're
Uh,
audible.
yes.
Okay. Okay. So I think it's visible, right?
Yeah, it's visible.
Yeah.
Okay, so okay, so what I was telling is that if we show a spice bottle from a rich household and a poor household, and we give this to the image classification model, the bottle from the rich household will be actually labeled as spice bottle, something like that, and the bottle from a poor household, which actually contains spices, what we label as a spice bottle. So there is this biasing of AI in a very different levels, even what we thought of, even more than what we thought of. So now let's come to AI bias. So why AI was created was AI or ML models we used it to reduce the human bias that we have created because of our societal conditioning, and AI has the potential to help human beings make fairer decisions, but only if we carefully work towards fairness in AI systems. So AI bias is nothing but an anomaly in the output of an ML algorithm, because there was an anomaly in the model itself, that is the algorithm itself, or the data that we use to create the model. Okay, now let's dive into some examples, real world examples of AI bias. So one example is a US healthcare system. So they used an algorithm which almost ran on 200 million plus people. So what this algorithm, why they use this algorithm was, when there are a lot of patients, they will actually input the data of the patients into this model and will actually predict whether this particular person need extra medical health care. Okay, extra medical care, like whether this person has to be in the ICU or more, something like that. So the thing was that this particular model actually favored the white. That is discriminating the blacks from this accessing advanced healthcare. So why it becomes so is that there was a variable that they use as the parameter in the model in which they train, in the data in which they train, because an attribute called race was used in the data that they used. And what happened is that mostly uh, due to some of the policies in US, the healthcare system, the black people can actually avail some kind of, some kind of incentives. So mostly their healthcare expenses was little less than the white people. But what our model understood was that as the people spend less than the white people, it thought that the time that they wanted extra medical health care, or the time in which they avail medical facilities, was little lower than the white, because it directly proportionated the need of medical health care to the amount that they spent on medical health care. But it was due to some of the policies adopted, which actually gives the black kind of incentives. So what happened is that always black people were predicted as doesn't need extra medical healthcare by the model. So this is some of the cases in which we are having this kind of biases uh, due to the attributes that we are selecting to train our model. And another example is Corpus. This is also a US product. It is called Correctional Offender Management Profiling for Alternative Sanctions. So what this simply means is that if you have a convicted person, and he is going to prison, so this model, after entering all the details of this person like age, gender, race, previous criminal records, all these things, it will predict if there is a chance for this person to commit a future crime or not. So one example I can give you is, there was this black girl. She is something like 12 year old something. She actually tried to steal a bicycle from a person. So, but she was immediately caught and she had to give back the bicycle back. And there was this white person, a white man who is actually 42 years or something, and he is he has a repeated criminal. He has committed previous crimes. So when the data was entered, so exactly at the same time, he also stole something from a department store. So what happened is that the cycle that she stole, that black girl stole, was exactly the same amount. I mean, with by the cost, has the same price as the amount of things that this white person stole from the departmental store. So then this information was fed into the AI, and the AI predicted that this black girl could commit a future crime, but this white person is not going to commit a future crime. But the AI was wrong. This white person again committed crimes, but this black girl didn't commit a crime again. So this is again a biasing towards the white person due to the data that it was trained to, because earlier, from the they are training this data through historical data, and in all the historical data they had more black criminals, and thus the AI come to the conclusion that this black girl is going to commit a crime again. Okay, another example is that Amazon's hiring algorithm. So I think this is a famous example, and this algorithm was taken down by Amazon, and they no longer use this algorithm. So what happens is that Amazon has this fully automated hiring thing that if you upload a resume, it will actually decide whether you will be you will actually get an interview call or not. As they trained most of this algorithm with male resumes, the algorithm was more sure of the male person's resume, that the accuracy, the ML model was pretty sure of the outcome of the male. That is, accuracy and precision was very high for a male resume, and for a female resume, it wasn't. The model wasn't that sure because it hadn't uh, been exposed to that kind of data. That is with the gender female. So automatically it preferred more male resumes, and it was just because Amazon had more working force of male, and all their resumes was used for training this particular model. Another thing is the FB ads. It is also heavily gender biased. If you look at the job recommendations in the FB ads, for a female person, they will mostly recommend kind of secretary jobs, something like that, and for a male person, they will recommend jobs like drivers, something like that. So, we can understand that all these models, which we thought that will be unbiased, will make a fair decision, is also being biased like us, or is also making very systematic biases that we are being making. So, okay, this is another example. This is my screenshot, which I took like 2 hours ago. So if you actually search the word CEO for Google Images, this is the image that comes up. In the total statistic, it said that only 11% of the images is female and the rest is men. So that means that this kind of algorithms is also having the bias. That is, when you think of a nurse, it is a female coming up, even for the model, even for an ML model. And when you come to think of a CEO, a men's image is coming to is given as the result. Okay. So now we have to solve this bias. So how are we gonna solve this bias? So there is two step-by-step method to solve a particular bias. The only method that we can be applied to solve this is to find the root cause of the bias. It's not like how you make an ML model, like you pre-process the data, you clean the data, then you train the model, then you test the model, then you evaluate. There's no such well-defined method to remove the biases. So the only thing is we have to examine the data a lot. That is, a lot of human interventions is needed, and we have to think, where is this bias coming from, and we have to deploy different kind of methods for each of the scenario to remove the biases. So here I will be sharing with you different kind of scenarios and what are the things that they use to remove the biases. So, what are the sources of bias, and or how can we categorize the bias? Okay. So, the first thing is the training data. Of course, as we were talking from the very beginning, one of the main sources of the bias is the training data that we are using. So so you can see a word called negative legacy. So let's see what a negative legacy is. Okay. So negative legacy is nothing but the biases that is inculcated into the model due to the inherent biases in the data set. For example, let's say if any of you have worked in NLP, there is something called each of if you encode if you have used vec to vec, there is some association of the words, like you may know which words are closer to another word, just like a vector point, Just like you can calculate the distance between two vector points A and B, you can actually calculate the distance between two words, because each of these words are being embedded in a vector space, and there are something like the words which have the closest meaning are clustered together. There is something called association. So if you look at the association, the word female, if you check in the word female, the closest associated words that you can get is parents and wedding. And if you search for the word male, the closest association that you can get is profession and salary. And also there is another transformer model which we use for NLP, which is called BERT. So this BERT is considered as a state of art thing for the NLP, for all the NLP things. It does a translation, it gets a question answering, all those stuff. So when this even for sentimental analysis and stuff, so this BERT was given a sentence which is like, I'm Muslim, and it has to categorize it as whether it's a hate speech or not. Bird classified the sentence "I am Muslim" as hate speech. So why is this coming? So because Bird doesn't know all the politics of the world, but even though it is categorizing "I am Muslim" as a hate speech, so both these things, both these scenarios, that is associating male and female words to some category, and the birth classification of I am Muslim, even though both are NLP things, both have two different causes in which it was created. So we will discuss about what happened, why is the male and female words being associated differently. So the main reason why, behind that is because we are speaking English. Because the language itself, the English language corpora itself, is gendered. So what does that mean is uh, English language. What does it mean? English language is gendered is we have different adjectives and nouns for male and female. We have he and she for a male and a female, even though both are human beings. We use different adjectives for these people. If it is a female, we say she is beautiful. If it is a male, we say he is handsome. And if in a literary work, if we have to describe the hair of a heroine, we will just say she is having curly locks of blonde hair, long blonde hair. But we will never describe such a hair for a male person. So the language that we use is already gendered. It's already having a lot of biases in itself. It doesn't consider all human beings as the same. The language has a lot of gendering involved in it. So this language corpus is being used to train this particular NLP models. So one solution for that was to forget about the language, and we just encode. We just thought that we were okay. Let's encode this language into another. Let's use English, but let's encode the language in another way. So when we encoded the language, the gendering of the language was gone. So the language became gender neutral. In that way, it is a possibility of removing biases in language corpus. Okay, another example for this training data problem is the models that are used to predict whether if a loan is being granted for a particular person, whether he will be able to pay back the mortgage or the loan. So banks have this particular algorithms in which they will enter the person's profile and will predict whether this person will pay back the loan or not. So yeah, this is again being used in America. Of course, like the earlier cases, blacks were refused the loan because it was because in the history, due to our unconscious bias, let's take the cases data of a bank loan paying back and things. So if for the 10 or 20 years, bank managers never approve a lot of bank requests for loan were rejected by the bank managers just because they were blacks and they thought that they couldn't pay back. So that was our human bias. We didn't approve the loan because we have this unconscious bias that blacks may be poor and is mischievous or something like that. So we are giving this data. So what the model thinks is that it is given 100 data and the launch were granted for 70 whites and 30 blacks, and that means that there is more weightage for white. So it should be giving more, preference for white, just like the Amazon resume thing. So so that is another, that this comes under the category of the problems that caused by the training data. And the solution for this is either to use a alternative data source when it comes to the bank loan lending case. Instead of taking the bank's historical data in which the bank itself was biased, they could actually go for another source of data, from even from a different country, so that it is actually balanced. So it is not necessary that you have to actually use the data they have given you, but you should actually, okay, that we will discuss later because that is another topic. So that is one way. One solution is seek alternative data source. And another thing is that correcting the bias in the data set. That is what we did for the NLP thing. We actually corrected the bias. We can actually, tweak the data manually to remove the bias. First, we have to understand the bias, then we have to remove this bias from the data set manually. That's a lot of work, I know. Okay. So another thing is underestimation. You can see the word underestimation. So what is underestimation is no data is provided for that particular specific group. Just for this, just take the example of that Amazon hiring. There was no resume for a female candidate to be trained on. So the model doesn't know how to look, what are the attributes to be associated, or how this female candidate should be assessed. So there is no data on that, and they cannot actually, the model was not sure about the percentage of accuracy for the female candidates. Another example that we can say, when, for example, in Kerala, it was only recently we know that in our application form, the column, for the gender column, there was male and female. Now there's a column called other, which refers to the all the non-binary category. So it was very recently appended. So if you are giving a creating a model which actually predicts, if you are entering the profile of the person, whether they will get a government job or not, we don't have data regarding non-binary gender. So how are we going to predict whether this person will get a government job or not? So these kind of things are called underestimation because we don't have enough data about this particular case. So if we have lesser data about a particular group, AI, the model will be definitely biased according to that. So then the solution for these kind of things, when you do not have enough data, that is when you have the case of underestimation, uh, the solution is data augmentation. I don't know how many of you have worked with images. If you have worked with images, data augmentation is a very natural thing that you do during your pre-processing steps. You clean the data, then you augment the data. That is one of the steps that you do. Data augmentation is mainly mainly used in an ML. It's used as an ML technique when you do not have proper data. For example, when it comes to images, if you only have 100 images, but you need thousands and thousands of images, what you do is you take that particular image, you rotate the image 90 degree, 180 degree, you flip the image horizontally, vertically, you apply many filters on it, black and white filters, many color filters on it, you skew the image, a single image. So from a single image, now you are getting 10 different images. So similarly, now if you had 100 images, now you are having 1,000 images. So in order to increase the volume of the data, when you don't have enough data, you tweak the existing data, you augment the existing data to create more training data points. So similarly, you don't have data regarding certain groups of people or certain groups, let's say certain groups. So what you do is you take the existing data, you augment it with the true labels, true label manually or using some tools. You augment it and create the necessary data points to represent the underrepresented categories. So that is one of the solutions for underestimation things. Okay. Okay. So now let's move to the next source of bias, that is the algorithms. So there was this kind of model which was also biased to race and ethnicity of a model. When they were actually analyzing the model training data, what they said was that the training data was fine. The training data was, there was nothing which signifies the race of the person, the ethnicity of the person. There was no attribute which actually said that this is the race of the person. So how come the training data was fine? Then how come the model become biased without even race? We can call these kind of data as protected attributes. Okay, we call it sensitive attributes or protected attributes. These are the kind of attributes which actually makes a model biased. So from now onwards we call such data okay, protected attributes. Okay, so for this particular training data there was no protected attributes, yet the model was biased. So the thing was that they had another attribute called, that kind of things are we call model is blind to data. We call it as blinding to data because there was no such training data, but no such attribute, yet it was biased. So the thing was that there is something called zip code, something like a pin code. So zip code as a training attribute. So each of this community, like blacks, whites, or different ethnicity,
Hello. I think Anusree, you are not audible right.
Yeah, even for me, sorry,
Yeah.
I think the connection has gone.
Just a sec. I just follow something.
am I audible now?
Yeah, you're audible.
Yeah, you're audible.
Yeah,
A lot of problems with my headset. One second. Okay. Okay. So did you hear the thing about the zip code?
Yeah,
Hello.
yeah. Hello.
Did you hear about the thing about the zip code?
yeah, you can just repeat the last two, three lines.
Okay. So even though we call these kind of models as blind to data, because even though there are no such attribute, it's actually inferring those things from different other attributes like the zip code, because the community people live as communities which actually represent their race in an indirect way. So this model was actually learning the race from the zip code. So, so there was this model which is similar to the non-linting model that we discussed earlier. It actually learned this kind of information related to race and ethnicity from the surname of the people. Okay, so this kind of surname and zip code is actually the attribute which serve as the protect, which actually it is called proxy discrimination. Proxy discrimination actually means we actually don't provide this kind of sensitive or the protected attributes, but some other attributes is proxying for it. So that happens. So that kind of condition is called proxy discrimination. So what we can do is locate the intermediate computations within a model that create proxy features and replacing them with values that are less correlated with the protected attributes. So that is what we say. We don't blindly follow a particular method to remove the bias. If I said earlier that we don't have to use protected attributes like race or ethnicity, but we didn't use. But again, we had bias. So what we have to do is we have to go into the computation that is actually happening and which all attributes are acting as proxy features. Then we will have to consider, maybe we will have to delete those features, maybe we will have to encode those features into another form, something like that. So you actually have two options for actually removing these kind of biases. Either remove those attributes like a race, surname, something like that. Instead of surname, you can actually provide a user ID. So replacing it with some kind of encoding that can help. So and also another thing is that you can actually instead, so one of the main things that comes to the people's mind is removing the attributes, like removing the information like race, removing the information like ethnicity. But instead of that, one thing you can do is one thing that have actually proved that have worked is that adding more attributes that is relevant to a particular data. For example, there was this model which actually predict whether this person will be imprisoned or incarcerated in the future. So the information that we had was age, gender, previous criminal records, and few something, race, ethnicity, address, zip code, something like that, and all the basic information about a person. And of course, the model was biased towards the black people. And what they did, instead of removing the column of you know race, what they did was that they added 10 more attributes which actually corresponded to their education, level of education, from where they had got their education, this substance abuse, if they have used, they had done substance abuse, something. So all these other attributes, 10 attributes, which will be playing a major role than a race or ethnicity, something, a race and ethnicity. So by adding features which are more relevant to the data, can also help reducing the bias. So that is one thing that you can do. So basically, to summarize, you have to pre-process the data to reduce correlation between outcomes and protected characteristic. And another thing you can do is produce a representation of data that do not contain information on sensitive attributes. That is called counterfactual fairness method. So so that the sensitive attributes or the protected attributes doesn't affect the prediction. So another solution for this is using, transfer learning. Transfer learning is one efficient method in reducing biasing. Uh, Another method is, using a prediction after they are made to satisfy certain fairness constraint. That is, we have actually trained the model, we are getting the prediction. So after getting the prediction, we are actually comparing it to some fairness constraints. Then we are actually giving that as an output. Okay. So now we have this. So I asked you, where did you get your data from to train your model? So maybe you will use the data set that is available in Kaggle, or you scrape the data to get the data from for yourself, something like that. So if you are asked to create a model to detect the face, that is, I need a model. If I give an image, it will detect whether it is a face, human face or not. So two folders that you will have is, one folder you will have a lot of images of faces, lot and lots of images of faces, and another folder you will have a lot of images that are not faces. That can be anything. It can be a car, it can be a bed, it can be a laptop, so many things. So there are two. So basically, it is a classification problem, a binary classification problem, whether you detect whether it's a face or not. So that is your data set. Now let's go into each of these classes. That is, let's take the data which contains the faces. So what will be the composition of the face? Composition of the kind of faces, the features of faces that you will have. So if you actually look at the real world scenario, China have the largest population, followed by India. That means at least a fair population of that faces should be Chinese faces, and at least some at least 10% that of the faces should have Indian kind of features, something like that. But in the open source data that you will get, it will be mostly American faces or European faces, and a little number of faces like Afro Americans, something like that. So that actually doesn't reflect the real world composition. So let's take one feature. For example, for a face, we can have different things. You can have the skin tone, you can have color of the hair, color of the eyes, whether they wear a hat, or whether they have a glass, whether they wear glasses or not, something like that. So let's now take focus on one feature, that is the color of the hair. So when we actually take the real world scenario, it is actually like 75% of the people have black hair, and it is like 18 percentage of people have brown hair, 5% have blonde, 2% I've read here. This is a real world. Okay, that is a real world scenario. And the gold standard data set that we will get from this kind of uh, data sources that you actually use is something like the second image. That is mostly majority of them will be blonde and brown hair. That actually doesn't reflect the real world scenario. So how your balanced data set should actually look like is something like the third image, which is like a fair contribution of almost all the hair colors, such that the machine learns or the model learns it without any biases. So that is one way of creating balanced data set. That is examining yourself regarding the composition of the data. Then um, then actually you know, re-including the data set. So how can it be, how is this possible? For example, if you have 1 lakh of images, how are you gonna, now it is easy because we are just taking the color of the hair. But when it comes to so many features like color of the lips, color of skin tone, so how are you going to ensure that the data set is even? That is, it is evenly distributed, it is very inclusive. How are we going to do that? Can we do that manually? Or should do we have some algorithms for that, or should we develop some methods so such that our model is not biased? So one method that we employ is this. Okay, don't get scared. so this was a problem. That is, we are actually creating a model to make a complete analysis. So the thing is, he is to she is a given thing. So now we have to predict what is doctor is to. So this is a biased model's prediction. Okay. So the biased model predicted is doctor is to nurse, nanny, fiance, maid, something like that. How is it possible? Like he is to she means different gender of the same category. So doctor is to should be something another category of a doctor, some who is a doctor itself, but who practice another things like maybe a dentist, surgeon, physician. But our model is so biased that it actually compared he with a doctor and she with another. She is a gender, so it is actually biased. So we thought that she cannot be a doctor, so she should be some other profession like maid, mother, something like that, nanny, something like that. So how can we reduce this bias? So here the thing that causes a bias is the gender. So how will we remove this gender bias from our data? Are we gonna delete that attribute called gender? No, we are not going. We are not going to do that. So what are we going to do? So what we will do is now instead of predicting, let's assume that we have a model uh, which actually predicts the job occupation of a person. So we are having a lot of attributes. Let's say 12 attributes regarding a person. When we enter it, it will predict what is the occupation of that particular person. So that is Y. Okay. So X is our input, that is the 12 attributes, and Y, the occupation, is our output. And also, now we are adding another thing. Now we are having two outputs as the prediction output. That is an attribute called Z. That is, we are actually taking out that gender column, and we are actually giving this, instead of this 12 columns, we are now giving this 11 attributes and asking our model to predict if this is the characteristic of a person, what will be its gender and what will be the job. So now we are predicting two things, job and gender. So now what are we going to do? So now we have this input. Now inputs are decoded into input embeddings, and they are passed to the hidden layers, and then they finally predict two things. That is the job of the person and also the gender of the person. So now we have the probability of the chances that this person with this job is this gender. So now what we do is retract, and we there's a gradient, you know that, right? When we actually how these things work is by calculating the gradient, right? So what we do is while we have this gender, there's a gradient associated with it. So we take the negative of that gradient and we again back propagates it with this negative gradient. So what happens is that it tallies off, the biases goes off because we are passing the negative gradient of the bias. So what we actually did is that we actually calculate the probability of how biased our system will be given this particular attribute. And we actually calculated that bias and we backpropagated the negative gradient and we removed the bias. So now you can actually uh, now you can actually use the gender column, and this gender column, which is a sensitive attribute, which is a protected attribute in our case, is not in any way gonna bias our output. That is, it's not gonna play a very major role. That is, gender is not considered as a great factor when it's gonna output a task. So instead of removing that attribute from the data set, what we are gonna do is we are gonna remove the bias caused by it by backpropagating the negative gradient caused by that particular attribute. So what will be, uh, what will be the thing that is not going to work out with this kind of solution? Thing is that, let's say there are 44 attributes for a particular data. Now, or let's say it's an image. It's an image. Now we don't have an attribute to specify. It's just an image. We are passing an image. So what are the parameters that we are going to check for biasing? We don't know which are the parameters that we have to check the bias. Now we have a specific column called genders to check. What if we have 44 parameters? Are we going to check all these 44 and backpropagate it with negative thing? Or are we? What if it is an image? How are we going to do this? We don't even know how this model is actually calculating the attribute with these pixels. So that is one of the drawbacks of this particular solution, because we ourselves is biased and we also have to decide the parameters on which makes it biased. So that is ridiculous. So so we have to move to another solution in which we don't decide the parameter, but the algorithm decides the parameter which is causing it to be biased, and thus it is reducing the bias. So that is the next slide. Okay. Okay. So let's getting interesting. So you can see two images here. Okay. So this is the set of images that I was talking about. So if we take our data set with the faces, now we have a folder with a lot of faces. If we take our data set, almost 80% of our faces will be like this. 80% of our data set is like this. Maybe only 10% of our data set is like this. Okay. So there are two cases. Now. So we are now going to check what are the proportion of the presence of each of this. Like we are not. So we need certain kind of features to check for this. Okay. That is some features. So now let's take skin tone. So here what you can actually easily identify is the skin tone. So skin tone is a feature, and now we are going to check how overrepresented it is or how underrepresented it is. For example, if you say fair, how much overrepresented this fair attribute is in our data set and how much it is underrepresented, how much this dark skin people is underrepresented, how much is fair skin people overrepresented. The reason why we are checking this and reducing all these biases, if we have a lower data set with people with black hair or black skin tone, what happens is that when if we actually pass a image of a person who is having black hair, this model will sometimes won't even predict that it is a face, because it is actually more trained with people who are with blonde hair or brown hair. So that is why we are actually doing all this stuff. So now we are taking each feature and now we are going to check whether it is overrepresented or underrepresented. So so if we plot a graph, this is a point where these kind of faces or the skin tone thing comes. It will be like in the peak. These kind of skin tone will be overrepresented and these kind of skin tone will be underrepresented. So now we have to remove this. So how are we going to do that? So before discussing that, there is something called latent variable. Okay, so latent variable is nothing but a variable that we cannot observe. So what does that mean? So it just simply means that it is not a variable that as a programmer that I provided to the model. I never gave that kind of variable during the training phase or modeling phase. I never declared such kind of variables. these kind of variables are understood by the model, created by the model. Like when if you are talking in the case of deep learning network, it's you in the hidden layers. These kind of variables are created to make sense about the data. So it's not us; it's the model who is actually creating these kind of latent variables. To give an analogy of what a latent variable is, it's just an analogy. Don't think that this is how it works. So, for example, we are having a movie recommender, and we are having a lot of features to recommend a movie. I have a user, and I'm actually using age, gender, country in which that person is living, then what his her friends list, and what are the movies they watch. All these features to recommend a movie for a person. So these are the features that I'm going to consider. And this person is actually, and his or her watch history is like Terminator, Rambo, Matrix. These are the films that this person watches. Okay. Once again, Terminator, Rambo, and Matrix. So maybe the latent variable, the model actually, understand itself is called genre. That is, this genre was never, inputted as an attribute by us, but the model understand that one of the things that is common in all the things is genre, that is the action. So this person is liking action film, so I'm going to recommend more of action films to this person. So this genre attribute was never given in our data set, but was actually made with this data. The model actually made sense and created a latent variable called action to make the prediction easier. So in order to say, it actually used a higher dimensional data to create a lower dimensional variable, such that it makes the things to predict the things, make the calculations easier. It uses, for example, we had so many attributes like age, gender, watch history, so many things. So it took all these things and created another variable which is in lower dimension, which is just a variable that is action, which is just a one dimensional thing. So that is what a latent variable is. So we can actually understand this. So this is something that is created by the model. And in order to understand that, in order to understand what the latent variable is, we do something called factor analysis. So factor analysis helps us to understand the latent variables. So if we have, this is being used in models called generative models. Okay. So generative models uses these kind of approach. Generative models are nothing but a combination of deep learning model and a probabilistic model. So we are using the idea of latent variable to create to remove the bias. So how are we gonna do this? So what happens is that we actually give input the data set, that is the data set, this data set that we have as an input. This is the latent variable. Okay, so it understands the latent variables in this. So so we actually plot a graph of the distribution of the latent variables, as you can see here, and understand which latent variable is overrepresented, which variable is underrepresented. So taking that probability, we will understand that these are the variables that is underrepresented. So I have to give more of this data to make the model less biased, or this is overrepresented, or I have to remove some of the data from these kinds to make the model unbiased. So what we just did is we inputted data, we understood the latent variables, we understood what is the probability of each of the presence of each of this latent variable. According to that probability value, we are realigning our data set to train. So to come to the math of that, this is the math of it. So what happens here? Okay, we're gonna we're gonna understand this. No worries, you're gonna understand this. So so we are doing this. No human intervention is coming here. It is fully automated. So it is an automated debiasing using latent variables. So first, we have to calculate something called estimated joint distribution. Okay. So the thing, this function calculate the histogram for each of the latent variables. Is it clear?
Hello, Anushree, you are not audible.
Am I now?
Yeah,
I don't know what happens. I have to constantly refresh for me to get updated. Okay, are you able to see the screen?
yeah, it's visible.
Okay. So our latent variable was z. This was a latent variable that we actually inferred from the given data. So what we did is we calculated histogram for each of those latent variable with the given data. So then what we did is we multiplied each of this latent variable, assuming that each of this latent variable is, independent or exhaustive of each other. So assuming that the latent variables are independent and there are no dependencies on each other, we calculate this QI. We calculate the histogram for each of the latent variable. We multiply the latent variable. So what happens when we multiply the latent variable? We get the estimated joint distribution of the latent space. There is something called latent space. So we get the distribution of latent variables in the latent space. So that is what we are getting. So after calculating the histogram of each of the latent variable and multiplying each other, we get the distribution of latent variable in the latent space. So now now I'm taking a data point. Okay. So now I have a data point. So now I have to consider by including this data point in my data set, will it create more biasing or not? So that was the whole point, right? We have to decide which all data points that we have to include such that it is properly distributed. So the aim is to understand whether this particular data point is eligible to be in our data set or not. So what we do is we adjust the probability of that. So what we get is adjust the probability of that instance being in our data set. So what we do is we find the inverse, that is 1 by inverse of the approximate joint distribution across the latent space of that particular data point. So taking the inverse and adding a biasing parameter, we will actually get a value which is proportional to the probability of selecting that data point. So with that value, we will understand whether this data point is eligible to be in the data set or not. So what we do is we take the inverse of the approximate joint distribution across the latent space of that particular data variable. So when we get that value, we know whether this data point is eligible to be in our data set or not. So once we have that value, wow, it's done. We now know which are the things that has to be done included in the data set or not. So that is one way. Another way in which you can automate the process using latent variables. So let's now relax and come back to the fun stuff. Okay. So what are the 6 potential ways forward for us as an engineer in artificial intelligence, or somebody as a businessman who is actually creating the products? So one way is this. So the first step is to understand the importance to, there's an importance to anticipate the unfair biases of the model, and the it has to be updated regularly. It's not like that you created a model, you deployed it, and you never cared for it again. It's not like that. You have to constantly check whether this model is becoming obsolete or creating more biases because the situation, there are cultural changes that is happening. So it is very important to anticipate for unfair biases. Second point is we have to establish a set of tools and procedures. We will discuss about the tools in the next slide. So we have to use a set of tools and procedure while you're creating an AI solution. So so these tools highlight the sources of biases in data. Like it's like when we have 1 lakh of data, how are we going to understand whether this data is biased or not? So when we have this huge amount of data, we need some kind of tools to tell us that whether this data that we have got is biased or not. Only then we can understand that we have to uh, check for another source for more reliable or unbiased data. So for that, we have a certain kind of tools which actually tells us that whether this data is biased or if certain attributes in the data is influencing the model to giving that particular prediction. That is how much each of this attribute is contributing to the prediction and how much biased the data is. Or we can have a have a third party help other than the programmers to audit the data. It's not the programmers. We can have a third party to audit the data. Then the third method is during the model building and evaluation, you should highlight the biases that have gone unnoticed. That is during the evaluation, using the different evaluation methods should actually figure out whether the prediction is biased or not. So if identified, you can actually improve it using retraining it, or using it, different process design or cultural changes, something like that. And fourth method. Okay, not everything should be automated. I know it's a trend that everything should be automated, and it's cool that everything is automated. But there are certain tasks that has to be done by human beings that has to be automated. If we can, I'm not saying that we are totally unbiased and we can make unbiased things, but there are some things that we have to use. We have to think logically, considering our social situation, and some interventions has to be done from our part. It shouldn't be a total loop that is automated. There has to be human intervention while creating this. Uh, like it should be a system like humans plus machines, something like that. This process is called humans in the loop process. It's called humans in the loop. So it's something like this. The algorithm make a recommendation, and the human double check whether that recommendation is unbiased or not. So that's it. That's one thing. Another thing is that research is very important in this kind in machine learning or AI, because when businesses have to be when it comes to researchers, you need data, and for data researchers, I mean businesses and people who are outsourcing the data have to provide us data without violating the privacy policies, or without violating our privacies, individual privacies or sensitive data. They have to be they have to be more generous in giving us data. And not just coders, not just business person should be involved in this activity, but it should be an interdisciplinary engagement, including social scientists, people who actually you know uh, there should be some kind of ethics in AI. For that, we need social scientists, people working in different fields to be involved in this, to actually understand the problem better, to understand whether the solution is actually working better. So it is AI is an interdisciplinary field. It's not just made up of programmers or coders or researchers. And yeah, first the last point is we have to diversify the AI field. That is, as a even for example, I will say this. I think this is pretty famous. Like during the initial days when Siri, right? So a woman was in a tense, difficult situation. She thought that she might get raped, so she needed help. So she said Siri that Siri, I think I'm gonna get raped. And what Siri replied was that, okay, enjoy your time. So why didn't Siri consider, while building Siri, nobody considered that there might be cases of sexual assault or rape. So we have to consider that use cases while building this. If there was a women in the team, women in this AI team, the first use case she would be thinking of when they consider about tackling the dangers won't be a heart attack. It won't be something like calling an ambulance or something like that. The first thing that comes to her mind will be a rape. So That is why we need people from diverse demography, diverse economic situation, diverse gender. We need people from every sections of the society to actually create a solution for the world. Otherwise, it would be not a solution for the whole world. It would be solution for a part of the world. So this is just a summarized version of what we have discussed now. And okay, I said before we have some tools to reduce the AI bias. So one of the tool is AI Fairness 360. It can be only used for binary classification. Uh, so um, so what AI Fairness does, 360 does is it tests the biases in models and data sets using some matrices and investigate the biases. It can also help in mitigate the biases with 12 packages that is available. It is actually available in GitHub. You guys should check it out. So this thing actually tests the biases in models and data set. And another tool is IBM Watson OpenScale. So it actually is how it works is in real world the AI makes a prediction and it checks whether that predicted value is biased and how this bias can be mitigated. So that is how IBM works. It is real world. It has to be used in the real world. While AI fairness is just for binary classification, we have to find another tools which can be actually extended for multi-labeling and stuff. And another thing is Google's What If. That is pretty wonderful. Google's What If. This is actually a GIF which actually show the working of the things. See that cursor is actually clicking on each of the data point. When you click on that data point, you can actually see the attributes here, and you can actually change those attributes here and say, what if I change a particular attribute? Where will this go? So in that way, you can actually understand how much each of these parameters contribute for deciding for particular thing. For example, if gender played an important role in biasing, what if I change that? If I click out this particular data, and if I change the gender with this category feature tag, maybe it may change the categorization changes, so that way I can understand that it is getting biased. And also it's not just clicking on it and changing the attributes. There are so many things available. It's like you can put in the hypothetical situation, analyze the importance of different data features, visualize them, visualize the model behavior. We can actually get kind of analytical view on how much in your data set, how much percentage each of these attributes have is playing a particular role. There's so many functionalities available. You should check it out. It is very simple to use. Actually, you can use it by integrating with Google Colabs. Even if your app is on cloud, you can use it. Not just with TensorFlow, even with other frameworks, you can test it. It's pretty wonderful. You should check that out. Oh, so that's all with the air biasing and how to mitigate the problems of air biasing. Thank you.
Uh, Thanks a lot, Anusree, for such a great session. Uh, Guys, if you all have any questions, we can have them now. So yeah, like you can either put it on the chat box or you can unmute yourself and speak. Yeah.
Any questions, guys?
Can you please wait just 1 minute? I'm writing my question.
Yeah, sure, sure.
It was not clear.
He's just
Well,
putting his question in the chat box. We'll just wait. Yeah.
okay, cool, cool. Okay. Okay, so the question was how will the career of ML engineers be affected? Usually, the question that I get is how will it affect other engineers rather than ML engineers? Okay, so this is the first time. Okay, as I said during the presentation itself, this process is no process can be fully automated or shouldn't be fully automated. No process should be fully automated because it creates a lot of problems, not just biasing problem. There are a lot of problems that can be created. So people actually engineers are now going back to something called human in the loop. That is, instead of creating a fully automated pipeline or a process, they're actually putting a human to uh, to actually test whether the predicted values are right or not. The recommend it actually makes the model not to predict but to recommend. They uses the word recommend so that the human will actually double check whether this not the prediction but the recommendation is right or wrong. So that is one thing that is actually gaining popularity now, and that is actually working a lot to mitigate the biasing problem and a lot of other stuff. So that is one thing, and another thing is that uh, you also the things you cannot actually major of the ML stuff, it's a trial and error method. You never, even though the fine tuning things and all these things, you can never really automate it. Uh, the whole stuff cannot be automated because even when it comes to data engineering, we have to think a lot on our own to make a sense of the data. For example, like if you it's something that happened in my team. We were actually building something like a Swiggy, a recommendation system for Swiggy, and we have this whole clean data that pipeline, everything was automated. So this data comes in, it gets cleaned, the model gets still, it gets predicted, all this stuff. But we have all kind of data, but the prediction was not coming accurate. So then we realized that the food that a person takes in or a person orders is also actually related to the climate, weather of that particular day. So from the latitude and longitude, we have to we have to calculate the weather of that particular at that particular time in which the person is searching. Then we have to make the recommendation. So a lot of things that is there that a person as a human being that we should think and understand, not just with the available data, but we will have to feature engineer a lot of stuff rather than the available data to make sense of the data. So human beings are always necessary, very important when it comes to ML, especially you can go out of hands if we don't actually intervene. Something like that happened in as I said before, the US healthcare systems.
Guys, if like anyone else has any questions, like you could put it in the chat box. Or I I guess then I don't. I guess we don't have any questions. So I hope you all have had a great time. And okay, so Rajat has one more question. So while learning as a student, we also learn the tools or keep the automation tools learning when getting into industry. Yeah, Anushree, like
So wait,
we have.
I'm trying to understand.
Actually, my question is that while we are learning as a student, we just directly, we just learn the underhood things of machine learning and algorithms and everything, or we should also learn the automation tools which are generally used in the industries, uh, or we just learn those tools while we working.
Kind of automation. What are the automation tools tools that you are
Automation
applying?
tool like currently where I'm working, I'm working as a machine learning intern somewhere. So
Mhm.
there also we use some tools we use Dockers to upload the images, to upload the models and to the servers and to the clouds. So these
Mhm.
tools are like we need to learn while we are in the industry. So my question is
Right.
like we learn these while I was a student because I'm currently in a currently doing my BTech, so I'm a student also. So I learn all these things while my learning time, or I just keep these tools to learn for the industry.
It's like it is not when you are applying for an AI position, they're never gonna ask you whether you're good at Dockers or something like that. So when we are focusing on interviews and hiring processes, they don't focus on this. If you are applying for an AI engineer, they don't focus on this.
Okay.
I think like is Anushree audible? Okay, she'll be joining again. Just a sec.
Okay, okay. So yeah, so it is great if you can learn all this during your college days. I think you will actually learn it during your colleges when you are actually doing some projects. You, for example, when it comes to Docker, you will try you like even for fun. Sometimes you will try when you're doing some projects in colleges just to know what a Docker is. So just having a basic knowledge is good enough. I'm saying that you have to be a pro in all these things if you have to work as an AI engineer, because anyway, as any engineer, I mean software will you will actually get to know all these tools once you're in the industry.
Okay, ma'am. Thank you. It clarified many things.
Um, I guess if anyone else doesn't have any questions, we can. Okay, one.
Thank you, Anushree. It was a great session.
Thank you, Arya, for the compliment.
Once again, Anushri, thanks a lot for a great session. Like everyone, I hope it was really resourceful and helpful for everyone who joined the session. And yeah, I guess we can wrap up the session.
Okay. Thank you, Utkarsh, for calling.
Sure.
Okay,
Thank you, guys.
there is
And
one more question I think in the chat box.
okay.
Do you have any general advice for us? The thing is, if we are aiming for the first thing is it's not like any other it's not like a development field. A is not really a development field, it's actually a research field. So you have to keep that in mind while you decided to enter this particular career. It's actually a research field. So if you are considering it as a seriously as a profession, and also as a beginner, when you're going for the hiring interviews, be sure that in the college days you actually learn all the algorithms in a clear manner, like you know when to use which algorithms, because the coding part is easy stuff because you are just using the pack or available libraries packages. You are never doing, actually you're not creating a neural network from scratch. You are just using different modules. So it is very important that you know all the basics, all the algorithms, how each algorithms work, when and where to use each of these algorithms, when to use deep learning solution, when to use random forest, all these things. So you have to be very pretty clear on these things.
Guys, I'll be sending out mails like you could just fill out the feedback form. So I'll like all the PPTs and the whole YouTube recording like for the whole session, I'll mail you. So just fill out the feedback form. I'll put it again in case someone missed it out. Yeah, I guess then we can wrap the session. Yeah. Once
Okay,
again,
sure.
Anush, thanks a lot.
Thank you everyone
Okay.
for joining. We'll have future sessions as well. So please keep an eye on us.
Yeah.
Bye, guys.